Will precipitation occur when the following solutions are mixed? If so, write the balanced chemical equation for the reaction. Well, I have put down the solubility guidelines for aqueous solutions to figure out whether a precipitate will happen or not. A precipitate happens when two aqueous ionic solutions come together and a solid comes out. So one of the products of the aqueous ionic solutions needs to be insoluble. Therefore, if none of the products are insoluble, then there is no precipitate. Let's go ahead and take a look at question A. We have Na2CO3 coming together with AgNO3. Precipitation reactions are double replacement reactions, and the way we can predict the products is by writing A for the first part and B for the second part of our ionic compound. C is the first part and Z, like here. And what happens in double replacement reactions is that partners get switched. So instead of A being with B, we will have A coming together with D and C coming together with B. Notice that whoever was first is still first, but they just switch their partners like on a dancing floor. So what we're going to have is we're going to have A, we have Na, and D is NO3. C, we have Ag, and with B we have CO3, and these formulas have not been checked. They're not correct yet. We need to figure out their oxidation numbers to make sure our formulas are correct. So for sodium it's +1 because it's on the first group of the periodic table. NO3 is a polyatomic ion that has a -1 charge or oxidation number. +1 and -1 cancel, so our formula is NaNO3. And let's do the same thing for Ag and CO3. CO3 is 2 minus, and Ag must be +1. Again, it's on the periodic. CO3 we memorize because it's a polyatomic ion that has a 2 minus charge. And Ag, we can look at our formula here. Since we know NO3 is -1, Ag has to be +1, so that their ratio is 1:1 in this formula. And I believe on the periodic table we will see that silver is always +1. And so our formula becomes Ag2CO3 because we put the numbers, we cross multiply these numbers. This one goes here and this one goes here, and we get Ag2CO3, I'm sorry. Now what we're going to do is we're going to figure out, is one of these a precipitate? Let's start with NaNO3. The big one here is Na. If we look at the solubility guidelines, it says group 1 ions such as Na are always soluble with no exceptions. So this is soluble, and we will put Aq next to it. This is always soluble. This is definitely not a precipitate. Let's go ahead and look at Ag2CO3. We can either look for Ag or CO3. Let's see if we find anything here. Well, I noticed there is CO3 here, and it says it is insoluble unless it is combined with group 1 or ammonium. Well, Ag is not group 1, and it is not ammonium, therefore this is insoluble. And when something is insoluble in water, it is therefore a solid, and we put a little s in brackets next to it, symbolizing that this is a solid. Therefore, Ag2CO3 is a precipitate. So this is our precipitate. This reaction will indeed give a precipitate when solutions are mixed. And we are going to go ahead and write it out clearly, and then we will balance it to make sure that this is correct. Na2CO3 was our reactant, and again we always start with aqueous reactants dissolved in water. AgNO3, also aqueous, and it produces NaNO3, just like we figured out aqueous, plus Ag2CO3, and this is solid. Now we're going to go ahead and balance the equation. We see that we have 2 NAs here and only 1 Na here. So we're going to put 2 in front of this formula, so our sodiums will be equal on both sides. Now let's look at NO3. I see that I have 1 NO3 here, and when I balance, if polyatomic ions stay the same on both sides, like I see NO3 here and NO3 here and CO3 here and CO3 on the right side, that means that I can just, instead of going element by element, I balance by polyatomic ions, which I find to be much easier. So let's go ahead. We have 1 NO3 on this side, 2 on this side. So I am going to put 2 in front of this molecule. Therefore, my NO3s are now balanced. And let's look at Ag. I have 2 Ag here, 2 Ag here. And the last one is CO3. I have 1 CO3, 1 carbonate on the left and 1 carbonate on the right. Therefore, our equation is balanced, and indeed, it does give me the precipitate. Let's go ahead and go to part B. Part B says that we are mixing NaNO3 aqueous is going to be mixed with NiSO4 aqueous. Again, this is a double replacement, so we're going to note it as AB+CD, and again, it always gives us AD plus CB. A is Na, D is SO4. Now SO4 is 2 minus, Na is plus 1. When we cross multiply, we will get Na2SO4. I'm going to write the correct formulas right away. CB, I have nickel plus, and I'm going to mix it with NO3. Because in this formula NiSO4 we don't have any subscripts, that means nickel's oxidation number had to be the same as SO4 to cancel. SO4 is minus 2, therefore nickel must be plus 2, and NO3 is minus 1. So we are going to cross multiply and get NiNO3 2. I'm going to write it out more for part C so we can see how to write the ionic formulas more clearly. Let's go ahead and see if any of these are precipitates. Sodium sulfate, again, sodium is group 1, and group 1 is always soluble, so this is for sure aqueous. And nickel NO3, okay, I found NO3 here, and look, it is also soluble with no exception, so this is aqueous as well. Therefore, part B, there is no precipitate because both products are aqueous. Okay, I definitely misspelled it. Give me 1 second. Let's write precipitate. No. Precipitate. No precipitate. Okay, so we didn't even have to write this equation, but we did. Part B gives no precipitate, so we will leave it alone. And let's go ahead and do part C. Part C, we have FeSO4, again aqueous. 2 aqueous ionic solutions are combining, and we will see if they will form a precipitate or not. This is combining with Pb, NO3, 2 aqueous. Again, we can divide this into parts. We can say the first is A with B, C with D, and then when we write it out, I don't have space, but it's going to be A with a D plus C with B. A is Fe, D is NO3. Let's go ahead and make sure we write the correct formula. NO3 is always minus 1. Iron could have different oxidation numbers, but looking at this formula, we see that it is 1-to-1 ratio, FeSO4. SO4 is minus 2, so iron had to be plus 2 to cancel it out so we don't see any of the subscripts. So iron had to be +2. We will put it here. And again, we take these little oxidation numbers without their signs and we cross multiply. And the formula we will get is FeNO3 2 plus, what is Cb? Okay, let's go ahead. Cb was Pb and B is SO4, Pb with SO4. Well, SO4 we know from polyatomic ions that SO4 has a 2- charge. Pb, again, we can see from this formula that the 2 next to NO3 came from Pb, so Pb had to be 2 plus. Our formula becomes PbSO4. Now we have to figure out, once we now have the products, but we need to know, is there a precipitate? Okay, let's go ahead. FeNO3, can I see? Okay, well, NO3 I see right away. Nitrate is always soluble, no exceptions. Therefore, this is aqueous dissolved in water. Let's do PbSO4. Do I have SO4 or Pb anywhere? Okay, I found SO4 here. It says it's soluble, except when combined with AgCaSRBA or Pb. Okay, it is combined with Pb, 2 plus, and therefore it is insoluble, and we will put little s to it, signifying that it is a solid. Now we know that this is indeed a precipitation reaction because one of the product is a precipitate, PbSO4 is a solid. What we're going to do last is we're going to balance this equation, so let's rewrite it clearly so we can balance it. FeSO4 plus PbNO3 2 goes to FeNO3 2 I'm running out of space, I'm sorry, plus PbSO4 solid. Let's go ahead element by element. 1 Fe on the left, 1 Fe on the right. SO4, I have 1 SO4 on the left, 1 SO4 on the right. Next, Pb, I have 1 Pb on left, 1 Pb on the right side. And finally, NO3, I have 2 NO3s on the left and 2 NO3s on the right. It is already balanced. We did not have to put any numbers, any coefficients in. It is good to go. This was Maya from Transformation Tutoring. Please subscribe, like, comment for more chemistry videos, and I will see you next time.